Hello coders, and welcome to our new tutorial series where I'm going to be teaching you how to create different types of character controllers. In this tutorial we are going to create a third-person MMO style character controller with a camera system attached to it. We're not going to be using any of Unity's standard assets because the whole purpose of these tutorials is to teach you guys how to create your own stuff. Alright, so I'm going to be using this little robot that I created. You guys don't need to use it, and in fact I won't have it available unfortunately because it's not ready to be published, but you guys can really use anything you want to follow this tutorial. You could use a cube if you wanted to. So again, there's no restrictions on any sort of character you want to use. This will work on anything. Alright, we're going to be trying to complete this in about 20 minutes, and we should end up with a pretty good feeling character controller in the end. Alright, so let's go ahead and get started with it. The first thing we want to do is add to our hoverbot, or to our character that we want to move. We're going to add a rigid body to it. So we're going to click on our character, go to add a component, physics, and rigid body. And for now we're not going to be using gravity, so uncheck that guy. Alright, and so let's go ahead and create the scripts that we're going to be using for this tutorial. Alright, so we're going to have a script for our character controller, and we're going to have a script for our camera controller. Alright, so let's go ahead and open up our character controller. We'll start off with that one, and if that'll open up anytime soon. Alright, there we go. Okay, so we have our character controller. We're going to start off by writing a few settings variables. Okay, so follow along with me here. We have a public float for input delay. The input delay is going to be our sort of input dead zone. Basically, the purpose of this is so that whenever if the player right when the player instantly presses the input button to move forward, it's not going to move forward. There's going to be a small delay. There's going to be that small dead zone from negative 0.1 to 0.1. All right, and the reason for this is just it's purely preference among certain gamers or developers. All right, so I went ahead and added it for that reason. Then we're going to have a float for forward velocity, so we're going to call that forward vel. We're going to set this equal to 12. All right, these settings that I'm using here I've already tested, so that's how I know to use them. You can go ahead and modify them if you want, though. So we're going to have a rotate velocity as well. I'm going to set that equal to 100. So that's going to be how fast we turn. All right, then we're going to have some private members here. We're going to have a quaternion for our target rotation. So quaternions are just objects that hold rotations on a scale from -1 to 1 on each axis. And it includes a fourth axis. We're not going to get into detail on that, though, but quaternions are pretty complicated creatures. But for the purpose of this tutorial, we won't be doing anything too complicated. The target rotation is just going to be responsible for holding the next rotation we need to try to turn to. Alright, so we have the quaternion. Now, since we're using Unity 5, we need to have a rigid body reference, so we'll create that, call it RBody, and then we're going to have our input floats. So we'll have a float for forward input and turn input. Alright, then we're going to have a property for our target rotation, because we need to be able to access this rotation from our camera controller, and we're just going to be returning, so we're just going to say return target rotation. We need to access this from our camera controller so that we know we can base our camera rotations off of our character rotations. Alright, now I'm going to go ahead and just write out the methods that we're going to be using. So I'm going to draw out the skeleton for this script. We're going to be using start. We're going to have a get input function. We're going to be using both update and fixed update. All right, so both update and fixed update. And the reason we're using both of those is because we're going to be modifying physics-based components. So we're going to be modifying the rigid body, and we're also going to be doing non-physics based updates, so we're going to be using the update event function for that. Alright, and then we're going to have two more methods for moving, for running. We'll say run and turn. So we'll have void run and void turn. Alright, so run is where we're going to be modifying our rigid body's velocity, so we'll go ahead and add that into our fixed update function. We're going to be calling get input, so we're going to be gathering input in our update function, and we're also going to be turning in our update function because that doesn't require any physics. Alright, so the initialization that we're going to be doing in start is first we're going to set our target rotation. Set target rotation equal to our current, so our initial rotation whenever we first spawn. And then we're going to get our rigid body. So we'll say RBody equals get component rigid body. And actually what I want to do a sort of check for this. So what I'll say is if get component rigid body. Alright, so if we have a rigid body, we want to go ahead and set that to RBody, else let's go ahead and notify the user that the character doesn't have a rigid body attached. So what I'll say is the character needs a rigid body. Alright, so that's just if we don't have that component attached. Alright, so the next thing I want to do, the final thing that I want to do for initialization is set the forward and turn input to 0. So I'll initialize those like this. I'm saying the forward input is equal to the turn input, which is equal to 0. Now our get input function is just going to say 2 lines of code. It's going to have forward input is equal to input.getAxis. We're going to set this to vertical. And then we're going to have our turn input equal to input.getAxis horizontal. Now if you don't know what the getAxis vertical, getAxis horizontal means, go ahead, go to Unity, go to Edit, Project Settings, Input. Over here on the right side you'll see these different axes here. We're dealing with horizontal and vertical. So you can look into these to see exactly what we're doing. They have the buttons that you need to press to modify the values of these axes. Alright, so what you need to know is that the getAxis method returns a value from -1 to 1, and this is an interpolated value, so it can be any value between -1 and 1. Alright, so after we have our input gathered and we call turn, so now we can actually write the code that's required inside these run and turn methods. Alright, so run, what we're going to do is we're going to check for that dead zone, that input dead zone. We'll say mathf.absolute value forward input. Remember, we need absolute value because forward input could be positive or negative. Alright, so we're going to check if the absolute value of forward input is greater than input delay. Then we're going to actually be able to move. Else, what we want to do is 0 velocity. Alright, so we'll say RBody.velocity equals vector3.0. So again, if we're outside or if we're inside that input dead zone, in other words, the computer doesn't recognize our input yet, then we want to make sure that we're not moving at all. Otherwise, we'll say RBody.velocity equals transform.forward. Alright, so we're moving the run method is going to be moving our character on the forward axis, on his own forward axis. So we'll say transform.forward, multiply that by forward input. Alright, and then we're going to multiply that by our forward velocity. Alright, so the reason we multiply the forward input is because, remember, this can be positive or negative, so it's going to be what determines if we're moving forward or backward. Alright, so that's our run method. Let's go ahead and code up our turn method really quick. What we're going to do is set our target rotation here. I'm going to say target rotation is equal to Quaternion.angle axis. Angle axis is going to take two methods. It's going to take, what angle do we want to rotate to? So 0 to 360, what angle do we want to rotate to? And on what axis are we making this rotation? So the angle we want to rotate to is going to be, let's see, rotate vel. So that's going to be our rotate speed. We're going to multiply this by turn input because, again, just like forward input, this can be positive or negative. So it'll be what determines if we're turning left or right. So we're going to say times turn input, and we're going to multiply this times time.delta time. And the axis that we're rotating on is going to be vector3.up. So that's the global y-axis. All right, once we have our target rotation, we can go ahead and just say transform.rotation is equal to target rotation. So if I run this, I should be able to see my character moving around on the screen. All right, what I need to do first is add the component that we just created to the character. All right, and so all these default values are in there. So if I run, we should be able to see my character moving around. All right, now if you look, you can see that I'm trying to turn, I'm trying to rotate. So what I forgot to do was multiply by my target rotation. what I need to do here is say target rotation times equals. The reason is because if I just say target rotation, I'm just saying, okay, we're going to be, if rotate val is 5, that means I'm only trying to rotate to 5 degrees. And once I reach 5 degrees, I'm not going to be moving anymore. So I need to make sure I add this. So if you multiply quaternions, it's sort of like adding angles. So if I multiply, then I'm going to be adding to my previous target rotation. And of course, I also forgot to implement that dead zone effect. Alright, so I want to make sure I have this dead zone for my turn input just like I have it for my forward input, and make sure that I pass my turn input into there. Alright, so now if I run the game, so I'll go ahead and run, and now you should see me, and I can turn and move around on the scene, in the scene. Alright, and so I can go forward and backward and turn any direction I want. Alright, so now that we have the character controller done, we want to go ahead and script our camera controller. Alright, so we'll start off with the bare bones of the camera controller. Again, we'll start off by coding up some settings. So we want to have our public reference to our target, so we'll make that a transform reference. Then we want to have let's see, a public float look smooth. So how fast do we want to look at the target? I initialize that to 0.09. And then we'll have a public vector3 offset from target. So how far do we want the camera to be from the player? Alright, we'll set that to new vector3, 0, 6, and -8. So this was a value that I thought looked okay. And then we're going to have a public float for our x tilt. We'll set that to 10. So the x tilt is how far we want our camera to be rotated on the x-axis. The rotation on the x-axis is going to be a rotation up or down. So the x tilt is going to enable us to actually look downward on our target as opposed to looking dead on into the back of our target. So this is going to be an effect you see in a lot of MMOs, and a lot of, not just MMOs, but a lot of games where you have a third-person perspective where the camera slightly looks down onto the target it's following. Alright, so we have that x tilt variable. Now what we want is some more private members. We're going to have a destination vector. So this is going to be where our camera is going to ultimately move to. This is the goal position that we're going to try to move to. I'll initialize that to 0. And then we're going to have a character controller reference. So remember, we need this character controller reference so that we can access the target rotation of the character, and we can make our rotations on our camera based off of those character controller rotations. Alright, then I'm going to have a float for rotate velocity. This rotate velocity will initialize to 0. We're not going to actually modify this ourselves. We're going to be using a SmoothDamp function that modifies the rotate velocity for us. Alright, but nonetheless we still need it. Now I'm going to draw out the skeleton for this script, just like I did for the character controller. So we're going to have a set camera target, which is going to accept a transform. The reason we have a set camera target method is because I think that for a lot of games you want to have the ability to give the camera a new target to look at. There's a lot of different uses for this, so I'm going to go ahead and show you guys how you can create that method. This would probably be a public method, though we're not going to be really using it outside this script for this tutorial. But again, this would be a method that you call to set the target, set the camera a new target to look at. All right, so we'll go ahead and get back to that. We're going to have LateUpdate. We're going to be using LateUpdate because our character controller is making updates to its position and rotation in update and fixed update. Alright, and fixed update can happen multiple times per frame. Update happens once per frame, but late update happens only after the update calls. Okay, so by putting our movement code in here, so we're going to be moving and rotating. So by putting our moving and rotating code inside late update for our camera, it's ensuring that we're making movements and rotations based off of the most previous position of our character. Alright, so if you want, you can play around with this. You can put this code inside update, or you can try putting it in fixed update, and you can see some of the wonky behavior you get by doing so. Alright, so after we have late update, Then we're going to have two more methods for moving to the target, and then we're going to have a method for looking at the target. So look at target. All right, so we're going to call both of those here. So move to target is going to be called in LateUpdate, and look at target is also going to be called in LateUpdate. All right, so what we want to do in start for our initialization is just call set camera target. So we just need to set that target, and we're going to pass target here. So this might seem redundant because we're only doing this for the target we're going to pass through the inspector. But again, this might be a method you want to use to set new targets as your game runs. All right, so what we want to do first is set target equal to t, and then we're going to say, if target has a value. So if target is not equal to null, we're going to do something else. So if we don't have a target, we want to make sure we log that error. So log error, your camera needs a target. This is for our own convenience, just so we can, if we forget to add a target to our camera, we can see this. It might be a little bit more readable than Unity's default exception errors. So you're just telling yourself, hey, you need to add a target to your camera script. All right, and then we're going to say if we have a target, we want to check to see if that target has a controller component. So we'll say if target.getComponent character controller. All right. If it does have a character controller, we want to make sure we set our private character controller variable to that. So we can say char_controller equals target.getComponent character controller. All right, so else, so if our target doesn't have that component, we want to log an error. So we want to say else debug.log error. And we're probably just going to say, the camera's target needs this character controller. All right, so again, this is going to be more readable than Unity's default exception errors. And in this case, Unity won't even throw an error most likely. It'll just not work, and so adding this error is really going to help us out if we forget to add that to our target. Alright, so now we have everything set up. We just need to add the code for our moving and our looking at method. Alright, so our move to target method is just going to be moving the camera behind the target. Alright, so let's go ahead and talk about what we need for this. It's just going to be 3 lines of code. We're going to set our destination. Remember, the destination is the value, the vector 3 that we're going to be trying to move to. We're going to set destination equal to char_controller dot target rotation. So here we are accessing that like we said we would. We're going to multiply that by offset from target. So offset from target is how far away we want the camera to be from our target. And so what we're doing is we're rotating the destination point. We're rotating a vector 3 by multiplying the offset by a quaternion rotation. And so that's going to return a vector 3 into our destination. So what we have currently is a rotated point, but that rotated point could be anywhere in vector space. So what we need to do is add that rotated point to our target. So what we'll say is destination plus equals target.position. So we're making sure that the destination, that rotated point, is relative to our target. Okay? And then what we'll do is we'll just set transform.position equal to destination. Alright, so now if I run this, we should see the camera. Alright, let's go ahead and click on our camera. We should see the camera staying right behind our target. Alright, so I'll go ahead and drag the component we just created onto our camera. Make sure I add the target. Okay, so we have this target value we need to fill. So I'm going to drag my character onto that target. Alright, now if I run the game now, what I really want you guys to focus on here is the scene view. Alright, so if I run the game, check out the camera. Alright, check out the camera gizmo right here. Alright, now as I rotate my player, you can actually see the camera is staying behind the target. However, if I look into the game view, the camera isn't looking at our target, which is of course what we want. Alright, so we need to code that look at function. Let's go back to our script. So our look at target, what we're doing is we're rotating only on the y-axis, so we're going to create the float for our Euler y-angle. We're going to set that equal to mathf.SmoothDampAngle. This method is going to take several parameters. SmoothDampAngle is similar to a lerp. However, it's a little bit smoother. essentially. It's just a smoother method for doing so. So what we're going to do is we're going to pass a current value. Our current value is going to be our transform.EulerAngles.y, and our target is going to be our target.EulerAngles.y. So we want to match our target's rotation on the y-axis. And we're going to be referencing, we're going to pass our rotate vel as a reference. Remember, that's the value, that's the rotation value that we created up here. And we're not actually doing anything with it. Our SmoothDampAngle method is actually going to be modifying that all on its own. Alright, and so we're going to pass that reference, and then we're going to say smooth time. This variable is going to be our look smooth variable. That's going to be how fast we're actually looking at that, or how fast we're trying to look at our target. So once we have the Euler y angle, what we can do is we can say transform.rotation is equal to Quaternion.Euler. So what this allows me to do is return a, since rotation is a quaternion type, it allows me to return a quaternion by passing a vector 3. Okay, so I can pass a vector 3 to this parameter, and what it's going to be is I can pass a vector 3, or I can pass it as a component form. So I can pass the x, y, and z to it. I'm going to pass the x, y, and z, so I'm going to say transform.EulerAngles.x. So that's going to be whatever my x rotation already was. So essentially we're not changing that. And then we're going to pass Euler y angle to our y component. And then our z component is going to be 0 because we're not rotating on our z-axis. And that is going to complete the script. Let's go ahead and see the results of this. If I run the game, okay, we'll go ahead and run in full screen mode. I'm feeling pretty confident. Alright, so now I can move around. My camera stays looking at my target, and it stays behind my target as well. Alright, so that's going to conclude this tutorial. We went ahead and set up a basic MMO style character and camera controller system. Alright, if you like the tutorial, go ahead and drop a like. In the next tutorial, we're going to be covering jumping, which is going to call for some modifications to both of the scripts we created today. And looking down the road, we're going to be able to use our mouse to rotate around our character as you would expect if you were playing some sort of online game with a character avatar. Alright, so again, that's going to conclude this tutorial. If you like the channel, you're liking the videos, go ahead and show your support. Yeah, I can't talk. Yeah, so subscribe if you like us. Anyway, yeah, this has been a Renaissance Coders tutorial. Thanks for watching, and we'll see you in the next tutorial.